You've learned the distance formula. You have learned the midpoint formula. Let's put these two formulas into action, shall we? Well, it's going to be kind of hard for me to write on my laptop like this. So let's try something different. Oh! Probably scared me. Whew. Sorry to do that to you. All right, first example problem, here we go. Find the coordinates of the midpoint of line segment PQ with endpoints P negative 8, 3 and Q is negative 2, 7. All right, so first thing when you're going to use an equation, let's write out the equation. So the midpoint formula is going to be the average of the x's and the average of the y's. To find the average, we are going to add the two x values and divide by 2, because we have two of them. All right. Didn't mean to close that parenthesis. Divide by 2, comma, and the averages of the y values. So we're going to have y1 plus y2 over 2. All right. So y1, what are we talking about? What are these x's and y's? Why do we have multiple? Well, we have 2 points. We're going to call this one point 1, call this one point 2. All right. So negative 8 is going to be our x1. 3 will be our y1, because negative 8 is the first point, or the x value in the first point, and 3 is the y value of the first point. All right. So for q, we have x2 comma y2. So negative 2 is x2, 7 is y2. All right, let's plug these things in. All right. So x1, so we have negative 8 plus negative 2, that is over 2, comma, and we have 3 plus 7 over 2. Well, negative 8 plus negative 2 is negative 10. Negative 10 divided by 2 is negative 5. All right. So we get a midpoint of negative 5, comma, oh, that's just positive 5, because 3 plus 7 is 10. 10 divided by 2 is 5. All right. All right. So for our next question, we have m is the midpoint of x, y. So I'm going to draw this. So we have x, y, and m is our midpoint. X has coordinates 2, 7. M has coordinates of 6, 1. Find the coordinates of y. All right, that's a little trickier, right? So when I add 2 with another number and divide it by 2, I get 6, right? Because 6 is the average of 2 and something else. Well, let's see. Well, to find the average, I divide by 2. So that means if I got 6 after dividing by 2, I need to multiply to get 12. So 2 plus something divided by 2 plus something has to be 12, right? So that's 10, right? Because 2 plus 10 is 12. 12 divided by 2 is 6. All right. Let's go the other way. So if we start at 7, we get 1. I feel a negative happening here. All right. So I add two numbers together, divide it by 2, and I get 1. So that means when I add them together, I must get 2. So 7 plus something has to equal 2, right? So 7 plus something, I don't know what, has to equal 2. So, well, geez. That would have to be negative 5, wouldn't it? Because 7 plus negative 5 is 2. 2 divided by 2 is 1. All right. All right, sounds good. All right, that was fun with the midpoint formula. Let's use the distance formula. And remember, the distance formula is just another fancy way of talking about the Pythagorean theorem. All right. So, and the distance formula, I'm going to move this just for a second so I have more room to work. Yeah, that's not going to happen. Yeah, that's really not going to happen. Okay, so we're just going to leave it there, shall we? The distance formula says that we have to take the square root of the difference, or the length, the difference in the x values, x2 minus x1 squared, plus the difference in the y values, y2 minus y1 squared. All right, so this is our distance formula. All right. So, obviously there's an easier way to do this. We could just make our slope triangles, but sometimes we have points that are so big, that are so far apart that we're not going to be able to graph it. So we're going to use the distance formula. So f, let's deal with fg for starters. So f has coordinates of 1, 2. G has coordinates of, looks like 5, 5. All right, so x2 is going to be 5 minus 1 squared plus 5 minus 2 squared. All right, and don't forget, we'll have to square root it eventually. So that is 4 squared plus 3 squared. Oh, it's going to be 5, isn't it? And we're going to take the square root of this. That's 16 plus 9 square root. 16 plus 9 is 25. The square root of 25 is in fact 5. All right. So let's try this on the other side. And now I'm going to do it the other way. I'm going to use the slope triangle way. So this is 3 by 3. This one is 4 by 3. Well, 3 by 3. So this is going to end up, this is a 45 right triangle, isn't it? It's a special case triangle. So if I know that this is 3, then the hypotenuse has to be 3 times the square root of 2. And I know this 3 times the square root of 2 is not equal to 5. Kind of close, but not the same. All right, finally, use the distance formula and the Pythagorean theorem. They're pretty much the same thing. To find the distance to the nearest tenth. Oh, so I don't have to find it in simplest radical form. Well, great. I'm going to pull this formula. And so let's go with, this is x2, y2, x1, y1. So x2 is negative 2 minus 3. Take the square root of it, or square it, plus, and so we have negative 5, comma, 4, or minus 4. All right, squared. So we have negative 5 squared plus negative 9 squared, and we're still going to have to take the square root. All right, so we are ending up with negative 5 times negative 5 is positive 25. So we get 25. Negative 9 plus negative 9 is, negative 9 times negative 9, because that's what we're squaring, is 81. Okay, add those together, and I get an itchy ear. No, I get, well, 20 plus 81 is 101. 101 plus 5 is 106. So I get the square root of 106. Now, I don't know what the square root of 106 is off the top of my head, so I'm going to go 106, square root it, and it says to the nearest tenth, I believe, which is, there's a 9, so we have to round up to 10.3. All right, a baseball player throws a ball from first base to a point located between third and home, and 10 feet from third. What is the distance of the throw? All right, so, what do I know about a baseball diamond? Well, I know a baseball diamond is essentially, it is a square that's on its tip. And I know the base paths are 90 feet apart. So we're throwing it from here. And so the distance between these two is going to be 90 root 2. Okay. But we're not throwing it from first to third. We're throwing it from first to 10 feet away from third. So we're 10 feet away from third. So this is 10. All right, and we are trying to figure out what is the distance here. What is this distance here? Well, if this is 10 feet, then this has to be 80 feet. So we have an 80 by 90 foot base and height. and we're gonna have to square it, right, to find the distance of the throw, use the Pythagorean theorem, right? Okay, so here we go. So 80 squared, I'm giving you the answer. So 80 squared plus 90 squared, that's not what I want, 90 squared. All right, so we're going to add those together. It's an extra 0, we don't want that there. Take the square root. And so that throws about 120 feet, 120.4. All right, so those are some examples of using the distance formula, Pythagorean theorem, and the midpoint formula, everybody's favorite. Okay. Maybe not. Okay, so if you don't have any other questions, please go on to your assignment.